Hi everybody, welcome back to my channel on Feynman integration. Today we'll be re-evaluating this integral using King's property. Previously I evaluated it using Feynman integration by introducing a t right in front of that x, but today we're going to be using King's property. Just a quick refresher, this is King's property. It says that the integral from a to b of f of x dx is equal to the integral from a to b of f of a plus b minus x dx. And we're also going to be using kind of this obscure trig identity. It's not hard to prove. You can use it. You can prove this by utilizing the angle sum identities in trigonometry on pi over 4 and minus x. Yeah, like I said, this is easy to prove. Look it up on the internet if you want an explanation of why that's true. I'm not going to prove it right now. Just it's the angle sum identities. Just this is sine over cosine of this, and then sine of a plus b has an identity, and cosine of a plus b has an identity, and it works out to be this. So anyway, these are the two tools we're going to be using to solve this. All right, so our first step is we're going to make the substitution that x is equal to the tangent of u. So dx is equal to secant squared u du. All right, obvious. That's a fairly obvious substitution. Whenever you have x squared plus 1 on the bottom, that's a substitution you definitely want to try, because this will appear in the dx and right here, and they'll cancel out, so it'll make the whole integral a lot nicer to look at. So let's see what happens. So now we get I is equal to the integral. All right, so 0 for x would be tangent of 0, and if we had 1 for x, that is the tangent of pi over 4. So that's how our bounds change. Then we have the natural log of tangent u plus 1 over tangent squared plus 1, which is just secant squared u. And then we have the dx, which is also secant squared u, and then the du, so they would cancel out, and you'd just be left with this. All right, now utilizing this King's property right here, we know that this is also equal to the integral from 0 to pi over 4 of the natural log of tangent of pi over 4 minus u plus 1. And of course there's a du there, but I don't have room to write it. All right, so now let's use this property right here on this right here. So now we have I being equal to the integral from 0 to pi over 4 times the natural log of, okay, this tangent pi over 4 minus u is going to change to this. So we're going to have 1 minus tangent u over 1 plus tangent u, and then of course we have the plus 1, and that is du. All right, so let's see. What we want to do next is write that 1 as 1 plus tangent u over 1 plus tangent u. So we have the same denominator. And then if we add them together, we would get 1 minus tangent u plus 1 plus tangent u. In other words, it would just be, we'll just go ahead and rewrite this right away like this. 2. There we go. All right, so now we have I is equal to that. All right, let's use the properties of logarithms to split that up, because we know this is going to be the natural log of 2 minus the natural log of 1 plus tangent u. So I is now equal to the integral from 0 to pi over 4 times the natural log of 2 du minus the integral from 0 to pi over 4 of the natural log of 1 plus tangent u du. And all should notice that this is simply I. So this whole thing right here, that's I. All right, so now subtracting I, or I'm sorry, adding I to both sides will give us this. 2I is equal to the integral from 0 to pi over 4 and the natural log of 2 du. So, all right, well, that's going to be equal to pi natural log 2 over 4. So now we have 2I is equal to that. So I is simply equal to pi natural log 2 over 8. And that's what we got last time. And there is how you solve that using King's property. That's actually much easier than using Feynman integration. So anyway, there you go. Hope you enjoyed that.